I'm so glad to be here. It was a few months ago when we was sharing some teasers about Nitro, and everyone loves Vite, which is awesome. We have so long history with Vite, starting with Nitro Next version 3, which was more than 2 years ago, and I'm so much excited about today and things we are going to talk about. So first, I'm Pooya. I'm a creator of Nitro, H3 if you use the framework, and an ecosystem called OnJS, which is used by many frameworks, including Nuxt and other frameworks. I'm a core team member of Nuxt, and I work at Vercel. Also, if you want to find my social media, you can use my website. So first, let's introduce Vite to you. We all came for Vite here, right? It's coming from its documentation. Vite is fast. It literally means fast. Vite is generating a really optimized output, means for modern browsers using ESM. It's based on standards. It's not opinionated. It's made to work with any library. In fact, I was always amazed that Ivan was the creator of Vue, but Vite is always open. Many examples are React. So that's one of the really strange good parts about Vite. It's minimal. It doesn't have bloated features inside, and it's extendable. That's how we have an amazing ecosystem on top of Vite. That's how every meta framework, every library can make ideas on top of Vite because it's small and fast. And it's also a foundation for meta frameworks. So you can use directly in Vite for making your small projects. You can add any plugin you want and hack it, or you can use it through another meta framework. This is amazing design. But something interesting that the time that Vite was evolving, we was also working on Nitro Nuxt version 3. And with Nuxt, we needed a server. And interestingly enough, we was sharing basically all of these things. Not all of these, but also we had a shared friend, Rollup. So Nitro is the server engine. It was originally for Nuxt. It was meant to be really fast. When in dev you want to reload, it should just build your server. It should generate an optimized and modern output based on ESM. It's based on the standards. Actually, Nitro is designed to take away the vendor locked in. So any code that you write in it, even if it's vendor locked in, even if it's like a feature from a vendor, you write it in a way that works outside it. So for example, if you want to have redirects, you have route rules. And route rules translate to the vendors. If there is no vendor, we just handle it on runtime. It's based on the standards, based on ESM and web standards. Nitro is really minimal. That's how it's expandable and also used in other meta frameworks. I was really shocked when I first saw that other meta frameworks had started to use Nitro because we had some internal APIs and they just found their way to do it, even though it wasn't documented. And again, we use Rollup, same as Vite for it. So after all this time and using both of them for Nuxt, like we had Vite for building application, we had Nitro for building server, and sharing all of this, we was thinking, why we don't unify these things? If they are this close, which is a perfect tool for building your web application, Nitro is the perfect tool for building your web servers, why we don't combine them? And after almost 2 years, I'm so sorry for all these delays. Like every time we was saying, we are going to release it, and we delayed. It finally happened. We wanted to make sure we make something minimal, something that as much as meta frameworks can benefit from it, or you can directly use Nitro with Vite for having a full stack experience. And result, hard is in simplicity. This is the result of the work. If you have a SPA application with Vite, you want to make it full stack like any other meta framework, you have to just add a plugin, and you have all the benefits. You have several routes, so your SPA application has API inside it. You don't need to have a separate backend like Express. It bundles your index.html, so unlike usually that either you have a static hosting or you have to serve the static file yourself with Express, it bundles it perfectly. It has native integration with Vite Environments API, so in conjunction with any meta framework like Tanstick Start or Solid Start or Nuxt very soon, it just works. It's designed to magically work, and it's not locked to anything. Also, you are deployment agnostic, so whatever server you make, it's ensured that it works where you deploy it. And also, it automatically integrates with SSR. So other meta frameworks basically don't have to do anything. Like if you have meta framework that has SSR and Vite Environments API support, it works with Nitro in an agnostic way. Before going to the details, I'm going to show you something really strange, but it was, believe me, it was pretty normal like a few years ago, and it's all, even today, it's this architecture being used by most of the frameworks. So you see, if you have an SSR application, it's really hard. Basically, the reason that meta frameworks with SSR exist is because it's hard. And we had this problem for a long time. If you take a source code, you have some like Vue or React JS files or Vue application, bundlers and frameworks, they have to build it twice. They have to build it one time for the server, they have to build it one time for the client, they have to make a shared manifest, and then we have to combine them somehow into a server that you can deploy somewhere. And it's really hard. So for like era before Vite, we had to use Webpack. We had multiple entries for client and server. At some point, we also had this third one for like SSR client and the server. And then we had to fit this, like take example like Nuxt. It has to build all of them. It has to fit it into the Nitro builder. And Nitro had to add anything that is for deployment agnostic part, and then make a production output. We identified this problem probably more than 2 years ago. We had been talking with Vite team. We had been internally prototyping how we can solve this problem. And it was also like a 6-month project that we actually made something similar to Vite Environment API. But because it was so complex and it was only for Nuxt, we finally discontinued that project. But after all the efforts, Vite happened. Like Vite with Environment API happened. The modern Vite happened. And now Vite is capable of doing everything that we needed. It's essentially a build orchestrator. Environment API, it has to be talked much more about. It's more than a build tool. Like a normal build tool is just like roll out bundles for you. But Vite Environment API can make an orchestration. So it doesn't matter if you have Vite, you have Vue, if you have React, if you have Vue and React, or if you have like 2 Vue applications, 1 React application, you can just extend the environments, like create as much as you want. It doesn't matter if server or client. Vite can orchestrate the build. And through something experimental called fetchable environments and web standards, we can actually connect these environments. Like think about like Docker. We can connect containers using networking stack. These environments could be connected through fetch. And that's how we are leveraging it in Nitro. Nitro, when you add the plugin, it creates an environment for itself for the final server that is aggregating all of them. Think of it like an aggregator. It creates and facilitates the fetching ability between the services and generates the build output. Build output is super optimized. It's fully agnostic. It doesn't matter where you deploy. It doesn't matter. It just translates it to it. And it's also magical because like we don't have any assumption about environments. We just know that we have to fetch the environments. So it's super easy. Also, dev is now much faster. If you remember the old flow, you know, this hard thing, it has to happen also in dev. Like every time you save, we have to go through the whole process. We have to take the source code, we have to build the part, and then we have to take generate a manifest, give it to Nitro, and restart the dev server. Of course, there are so many ways to smartly improve it. I mean, this is not that bad, but if your application size grows, it's not that good. But now we have a unified system. We can optimize much more because there is just one orchestrator. It can be smart about it. So when you use Vite and Nitro plugin to start your server, we just use Vite Dev Server, which runs in any runtime that you want, like Node.js or Bun. The frameworks or your custom setup with Vite defines the environments. If you don't define any environment, by default, you have a client and SSR. And then Nitro communicates with an RPC. So right now we have implementation for node workers. So in development mode, we create a node worker and we run all of the environments inside one worker with all HMR and loading. And also we can emulate any other provider. So Workerd for Cloudflare or any other provider. If we want to emulate it locally, we just swap it. And because it's abstracted, it's just an RPC, it keeps working. We have to just implement the RPC one more time for each, nothing else. And it's quite fast because we do nothing. So further ado, I'm announcing Nitro version 3. Nitro 2 was called Nitro Pack. Thanks to the community help, we have a new package called Nitro. So Nitro Pack is basically old version of Nitro, and Nitro is new one, version 3. we completely migrated everything off Node API while we love Node and we use Node APIs. Now we migrated to the web standards. It's super important because that's how all of this is possible. We can be agnostic, we can be fast, we can work with Environment API without making hacks. Is that we use web standards, still we use Node. So we have best of the both worlds. And with all the runtime supporting Node APIs, yeah, we can leverage both. Nitro 3, Nitro 2 was based on rollup with the complex setup because, yeah, it was fastest also. But now we can bet on Vite. So it's completely based on Vite and then Vite Environment API. It's way, way lighter. I will show you more in the slides. It's actually one of the compatibility layer we made is basically the fastest compatibility layer you can make on Node for web APIs in the market. And as a feature, we have less features. Just bring your own features. Yeah, we had some things like auto import. Some people love it, some people hate it. So we removed the extra parts. Now Nitro is just what people really wanted, like the minimum server that works. Nitro version 3 alpha is out today. Actually, I released it a few minutes before our talk, and I made a wrong mistake for release, but no matter what, it happens. So the version is out after 2 years. I'm so glad that I did it today with you. And the documentation is up. You can go to the vt.nitro.build. Thanks to Sebastian. That is, I think he's somewhere here. It's beautiful, and you can see the output about documentation. And I will show you more. So come back to the Nitro version 2. I mean, this is the norm in there. Like, you know, the node modules, the popular meme that's like a black hole, like, we didn't solve it. And Nitro was an exception. At first, it was small. We added more and more dependencies, but you know, some dependencies like bombs. Like you add a dependency, you don't know, it adds another and another, and the other one is like a type dependency, and it adds like 200 more. And even though we tried to so much fight them, some dependencies could not be removed, and the situation with Nitro version 2 wasn't good. Like 76 megabytes, it's really dangerous. Like we have 242 maintainers. Like imagine if one of these maintainers could be compromised. I mean, they are not hackers, but if system of one of them, npm access of one of them is compromised, the whole ecosystem is compromised. And this was huge. So we had to solve it. Some parts could be solvable before. Some parts needed dependency changes. Some parts needed to invent new systems like tracking dependencies to smartly bundle them, some of them to replace with the standards. And from this, we got to this. It's much closer to it. We have much less dependencies. We have much less like attack surface. We still have all the features like from the dependencies we had before, probably even more in some cases, and this still could be improved. Something to mention like about sizes, it depends on your platform. So if you want to just measure the node module size, because like when you download things like ESBuild or Rolldown, it downloads some binaries. So this is the pure JavaScript size, but it could differ. But yeah, this is something really faster. Also, your stars could be fast. The other part is the output size. Because we migrated to the standards, web standards, we don't need to depend on the Vite Node APIs. We could improve output much, much more. So yeah, it was always on my fantasy to run my blog, you know, on a floppy disk. And I was asking ChatGPT how many of it I can run. The minimum I can have 150 of like minimum size on a floppy disk. It's fucking awesome because you know, like if you do a du-h in your laptop, it doesn't show you 8 kilobytes. It shows you 32. Does anyone know why? Like if it's like 8 kilobyte file, but your file system shows more. Because your disk, the minimum size of chunk in your disk is 32 kilobytes when it's formatted. So you're wasting your like size, like disk by having 8 kilobyte of file inside it. It's that small. And this is, it might seem not that important, but when talking about production, when talking about cold starts, when talking about running like hundreds of applications in like one pod, it matters actually. And this is also health scrolls because like we remove so many things, we identify so many tree-shakeable things that could be just thrown away. And I think it's one of the uniquest part about the ecosystem that we made with Nitro, that servers are just what we need, nothing more than it. I don't have time to show the performances, but it's also amazing. It's one of the fastest in the market. Yeah. This is the normal server. I think this should be the normal. Express should I mean, I love Express, but this should be the norm. Web standards are super simple. If you want to, today, if you want to run a server, that's all you have to need. No dependency, no runtime, no Nitro, nothing. That's the standard, and that's what we are pushing for. So this would be the minimum server. We made an ecosystem of tools that you can also run this server in Node, but if you use Bon or Dino, it's natively supported. In most of the platforms, deployment platforms are also natively supported. And this is the building block foundation for every piece of Nitro, for communicating with environments, for production running, for also alting, even handlers, for example. It's the core of the standard. And also it could be your server. Like many times you don't need a library, so you can just run this code. And later, if you needed more features, migrate to Nitro, migrate to H3, migrate to whatever you want. But the standard is simple. And because this is a standard, now Nitro doesn't need to be bound to one framework. You can choose any framework that you like, because all of these frameworks export that .fetch key. It's like an object. So you can write it, but you can also export a framework that exposes it. And right now we have like 3 really good made frameworks, Elysia, Hono, and H3, which is H3 is in the core of Nitro. You can just choose one of them and just work and make a project with it. Every time you want to migrate to Nitro, just add Nitro. And because we are based on the standards, you are not locked in, not only because of your deployment provider, but not also because of the choice of frameworks. Everything is just like a puzzle piece that just perfectly matches. So this is good for a server, but I mean, immediately you would feel like, where is my router? I need more than one handler. What to do with that? And yeah, like your answer would be, okay, add a framework. I don't want a framework. So in Nitro, if you want to define an API route, you can use file system routing. You can also use configuration API. With this example, I add like a /route and /blog and ID for blog article parameter slug. And these are 2 different examples. Like in the first one, I use the standard. In the second one, I use another convention in Nitro. Both work perfectly fine. The second one is with H3. That is built inside Nitro. You can choose whatever you want. But the coolest part is that there is no router. We remove the router. When you compile this code, that's what happens. So we made a router that is compilable. It converts itself to some if and else's, which if you benchmark it's interesting, one of the fastest ways to make a router in JavaScript. Like every time I was talking with others, like they was making complex routers to make it smartly fast. This is the fastest, and we have so many benchmarks to prove that. And this is your router. This is the router that Nitro generates for us. That's how the server is this small. Like that's why we don't have to worry about the sizes anymore. And other part, if you notice, is that we are using lazy event handlers. So if you have a server application with like, I don't know, 200 event handlers, every time you call the start, you don't need to load all of the memory, because some of them should have like some expensive dependencies, like some code formatter or something. But because it's lazy imported, also in production, as soon as just one request comes, we have to load it. We don't have to block the whole server at the startup to just make it running. Nitro is built on an ecosystem called H3. H3 started as a framework that was basically like the HTTP server for Nitro, because we want to replace Express a few years ago. It got pretty much popular. It's like one of the most popular, I think, HTTP frameworks in the JavaScript ecosystem, but we don't usually market it because it's more embedded and used inside. But we are growing a community. It has more than 10 million monthly downloads. It's huge. And so far, it's 161 million. I'm so amazed because so many people just use H3. They just find it useful inside their solutions. We started to build our own router, which is now evolved to Routery. It's a compiler router. The compiled output that you saw before, you can use it yourself. I know so many like services, popular services, just use the router of this ecosystem. We have ServerX, which is essentially the part that we spend a lot of time in 2 years to make sure that we bring standards to Node instead of making Node the standard. So Node is good for itself. It's like a de facto standard for using inside servers, for file system and other things. But for event handlers, for like making a server, it's not the best. It's like a black box. Like a request comes, something could happen to it, like with middleware, and something could not happen to it. But Fetch API is explicit. So we made sure that we made the fastest possible standard adapter for servers inside Node. So we can move forward. We can have Node as first class. We can have Web Standards as first class. And we can also use ServerX by its own. It's also unifying the other small differences between different runtimes, because while it's based on like Dino and Bonon based on Web Standards, they have slight differences, but ServerX standardizes them. And the last thing is the cross AWS, because there is absolutely no standard for making WebSockets in the servers. So we made one of the best adapters that just works. You define your WebSocket handlers once, and regardless of your runtime works. And all of these are integrated inside Nitro to make an agnostic and a standard server. If you would like to be involved more in the community, you're more than welcome to join the Discord. And one more I'm going to talk about very soon, if I have time. So demo time. If you want to create a Nitro version 3 application, you have to just use npx create Nitro app. It's a great job by Sebastian. Sorry, I used AI for this image. You can create your application. You can also add it to your existing application. Just imagine you have a static application using Tailwind CSS. I always use Tailwind because I'm really bad at styles. You just add the Nitro plugin to your existing one, so you don't need to create a new project. Imagine you have something like this, like a web application that generates something like a codes. And Vite is great for it, of course, because if you have some scripts, if you have some styles, it compiles them, it optimizes them for output. It's super fast. But, well, it's static, right? So you need a server for it. With Nitro plugin, you can just have the same. Like when you add the plugin, you can have routes/code or something like that. And then suddenly you have a backend for your SPA application. And then you can use modern APIs to just fetch the codes and display it. But can anybody guess what's the problem with this? Like, what's bad with this about performance? This is slow. I mean, we did all these hard parts, like we made SSRs and we made all these complexity steps to make sure that initial load is fast. But to make that initial load fast, you have to pay a huge cost. You have to migrate to a meta framework. You have to add all the complexities, creating SSR client, making a manifest, and combine them to the server. It's hard. So you have to either choose like simple with Vite or complex with the meta framework. I mean, complex hidden behind the meta framework. How to solve it? Like, I was struggling for a while that I want simplicity of Vite. I want just Vite and Nitro, and I want SSR. I don't want to reinvent the wheel. I don't want something complex. And it is possible. So if you check the documentation in Vite about making a SSR application, it has something long about creating a server entry and how to prepare setup. But the gist is that you need, in your code base, you need a server entry that has to do something to render the whole server. Because we are based on standards and we are respecting the Vite conventions, if you just create this file in your Vite plus Nitro application, Nitro just detects it and says, hey, I saw it. I just set up SSR for you. And the setup is not magical also. It's just an environment. So it's just discovering the file, creating a service environment for you, make it fetchable, and connect it. So no magic here. It's just an entry again. But the interesting part is that this part, this is the magic that Nitro does. You remember, your index.html was fully static. So like, it couldn't have anything. Or you could have your own really complex server to split the file index.html file and replace the SSR result with it at some point. It just takes away everything. It just works like this. And if you want to see the result, it's this. You can see this is the result of that. It's streamable. So the thing that you write inside here, it could be actually streamed. Okay. We also made it a little bit steps further. I think I'm blamed for this, but this is what we additionally added. So the thing inside index.html renderer that adds this possibility is an engine called Rendu. We recently added to the H3 ecosystem. It's a hypertext preprocessor. It's similar to PHP. I have to give a lot of credit for it. And basically, it just gives you an ability to have server templates, a preprocessor. It's not a templating. It's just, it streams the content, and every time it sees something, it waits for it. So in this case, like in the quotes application case, when we have installer outlet, it's replaced with a fetch call, and it like goes to the HTML, finds a fetch, it streams all the content, like the chat, if you saw the demo, and then it continues to the rest. But you can do anything else you want here. You can actually fetch something else. There's another application that Sebastian and Benjamin created. It's like a full ChatGPT clone using Vite and Nitro version 3 plugin. It just works. It's so many good practices inside it, like database connection and like all the standards if you are more interested to see a real-world case of Nitro version 3 plugin. And if you have any more questions, I would be more than happy to answer you in the Discord. Thank you so much.